Alrighty, here we go. We're going to dive into circumference and the rest of this first lesson in Module 9. All right, so there is a pre-printed note sheet. Make sure you've got it in front of you, and let's get started. Today's learning target is going to be all about calculating circumference. So our learning target, I want you to write along here with me. I can calculate circumference. Calculate. We got a lot of C words today. Can calculate circumference. Then put a comma. Circumference and the radius, and the diameter of a circle. I can't fit that all on there. Of a circle. Okie dokie. Here we go. Notice I've got this picture over here, and we've got a couple of things we need to talk about. So put some dots, one right at the center, and then notice that going from the center out to the edge, this is the radius. Okay, the radius. The line segment here that goes across from edge to edge of the circle and through the center is a diameter. The diameter is simply two radii put together. All right, so we can say diameter equals 2 times the radius. Okay, or if you have a radius, or if you take half the diameter, you get 1 radius. There you go. All right, and finally, circumference. That's a word you will hear a lot of in this module. Circumference is basically another word for perimeter. That means it's the distance around. Let me fix that. Around the circle. There you go. Okay. So you've experienced or dealt with some of this stuff last year in 6th grade. So this is kind of like review and going a little bit more in depth. All right. There is a specific formula for circumference, and it looks like this: pi times diameter, just like that. Okay. Sometimes you might see it written this way: circumference is pi times 2 times the radius, and just realize 2 times the radius is the same as diameter. In fact, sometimes they'll write it this way: 2 times pi times the radius. That's just simply using commutative property to move the numbers around, but it basically ends up being all the same thing. Okay? Let's do a couple of these because I want to talk about different situations when you have your calculator and when we would use different approximations for pi. All right. Yesterday when we did our little measurement lab, we discovered that circumference and diameter are directly related by this value of pi. And so we're going to put that to use today. Okay. A circle with a radius of 4 meters. Okay, so let's just draw a quick circle here. Draw a radius, and let's label that as 4 meters. Okay. Usually, I am going to default to this formula and use this one all the time. You'll notice that problems in your textbook might flip-flop between the two, depending on what you're given. Frankly, if I can just get you to think it's pi times diameter, and if I have the radius, I've got to first get the diameter, and then I can go to town. And that's kind of like this first example. I have the radius of 4, but my formula, I always want to use diameter. So if the radius is 4, I'm just going to quick jot that down here. I know I have it on the picture, but then diameter is twice as big. That would be 8, or 8 meters. So now to find circumference, I'm going to take pi times the diameter, which is 8. Okay, cool. Okay, sometimes you'll see books like to put the number in front, 8 times pi, like that. pi times 8, 8 times pi, it's all the same thing. Now, if I leave it just with the pi symbol like that, that's exact. That's exact. You know that number pi, it goes on forever, never ever ends. So sometimes, and especially when you get in upper levels of math, we want to keep that pi symbol as pi, because then I know that it represents this number that's irrational. It goes on forever, never repeats, it never ends. It's just bizarre. And if I leave it that way, it's exact. Sometimes, however, we use an approximation. Now, in my day, before we had handheld calculators everywhere, we always used this fraction, 22/7 for pi. So, if I were going to figure out circumference this way, using 22/7, instead of saying pi times 8, I'd take 22/7 times 8. Now, you have this calculator, so use it, okay? Because frankly, on your MCA test, there's only 5 questions on the whole thing you don't get to use a calculator on. So let's go ahead and simplify this. Put 22/7 in on your fraction button. Multiply by 8. And you get 176/7. Now, that doesn't really make much sense to us because that's a huge improper fraction. So can I remind you what buttons to press on here to convert it? Okay. I mean, ideally, I'd like you to be able to go off to the side and divide this and figure out how many 7s fit into 176. Okay. But here's what I want you to do. So you have on your calculator right now 176/7. Okay. If you press the second button, and then the number next to the fraction button, because up in that second function menu, it has or shows you fraction to mixed number. Press that and you get 25 1/7. By the way, I didn't type it this way on your notes. So will you do this right here and put an approximately equal to sign? It looks like a squiggly equals. Okay. 25 1/7. Okay. And I guess this is meters. So I should be labeling all these naughty naughty. Okay. Cool. So if you ever use the fraction approximation, that's what you do. If I use 3.14, which is probably what you've used mostly, put the squiggle lines here. Because when I use 3.14, I have chopped off and rounded off that decimal approximation for pi. 3.14159. Okay, keeps going. We're chopping it off. Squiggly equals. Times 8. All right, grab your handy dandy calculator and type in 3.14 times 8. Then we should get 25 12/100 meters. Boom. All of these answers, 8 times pi, 25 1/7, 25 12/100, those are all representing this same circumference. It's a length around the circle. It's just a matter of what the directions say and which way they want you to tackle it. Alrighty? Okay, next. Circle with a diameter of 3.3 feet. If I say to you, leave pi as pi, well, hold on, let's draw a picture here. The diameter goes all the way across, 3.3. That's the value you need for the circumference formula. So really you can just take pi times 3.3. Okay, now you can leave it as pi times 3.3, or sometimes most textbooks will often put the number in front and then the pi symbol, and it's feet. Boom, that's exact. Okay, we haven't plugged anything in yet. Now, if I want you to start to approximate, make this approximately equal to, and we'd take 22/7 for pi and multiply that times 3.3. Oof. Now, this is going to be kind of wicked bad because we're kind of mixing fraction with the decimal. Okay. Times 3 3/10. Here we go. Now, initially on your calculator, you'll get 10.37, blah, 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 blah. When I give you, or if you are instructed to use the fraction approximation for pi, then please go ahead and use your toggle button. Turn this into the decimal or the fraction, the improper fraction. When I do that, I get this number. Yikes, 363 over 35. Now hold on. I can see by looking at that 35 can go into 360 10 times, and I'll have some left over. Go ahead and do the math that way, or press the second button, and then the number next to the fraction button, and that will convert your improper fraction into a mixed number. I get 10 and 13 35ths feet. Okay, a little more than 10. All right, probably on something like this, if I'm giving you a diameter that's in decimals, more often than not, I'm going to tell you use the decimal approximation. Put your approximately equal to 3.14 times 3 3/10. Go ahead and grab your handy dandy calculator, because let's be honest, I love math, but I certainly wouldn't be doing this. I'd say that's about 3. That's about 3, a little more than. 3 times 3 is 9. I have some extra bits above that, so it's going to be a little more than 9, and sure enough, it is. Let me boost this up a little bit. You get 10 and 362 thousandths feet. Wow, that's awfully specific. Typically, the instructions in your problem will probably tell you round to the hundredths place, or perhaps round to the tenths place. So follow the directions as far as where to round your decimal. But when you're doing circumference problems, find the diameter. Circumference is pi times diameter. See what they're asking you to use for pi. Are they asking you to just leave the pi as the symbol, or use the fraction approximation or the decimal approximation? Okay? All right, let's try a few of these now that we're warmed up. Here's a picture. This is an irrigation sprinkler. So think of those sprinklers that you have in the middle, and they just go round in a circle. Okay? They're asking you, this circular region that's getting watered, it has a radius of 14 feet. Yep. Then find the circumference and use 22/7 for pi. Okay? Circumference is pi times diameter. Write the formula first, so then we can start substituting. Okay? They want us to use 22/7 for pi, the fraction approximation. My diameter, oh wait, this is radius. The radius is 14. The diameter goes all the way across. That is twice as big. So we have to take 22/7 times the diameter, which is 28, or 28 over 1. Now, listen up. The whole reason they're asking you to use this fractional approximation is because the number 28 is perfectly divisible by 7. And that means when I do this calculation, as I'm looking at the fractions, 7 can go into 28 exactly 4 times. Don't believe me, use your calculator to verify this, but you should get exactly 88 feet. Okay? Because you get 22 times 4. Sweet, sweet, sweet. All right, here's another one. This is a circular little wading pool. The radius is 21 feet. Find the circumference of this pool. Okay? Circumference is pi times diameter. Get used to that formula. They say use 22/7 again for pi. 22/7, okay, fine. The diameter, I only have the radius. The diameter goes all the way across. How big is that? That's 21. This would give me a 42-foot diameter. All right, now grab your calculator. If you happen to see this, 42 over 1, when you multiply fractions, you can simply create one giant fraction. See if you can simplify any factors in the denominator with factors in the numerator and divide them out. And you end up really with 22 times 6, which is 132. Okay, 132 feet. Boom. Now, just to prove to you that this is really close, what if I had used 3.14? Come over here and add this in here. Use 3.14 for pi. So circumference, which is pi times diameter, that's approximately 3.14 times a 21-foot diameter. Now, there's no way that I'm going to do that by hand. So take 3.14 times 21, and you get this value. Oh, not 21. What am I doing? It's 42, silly. Good gravy. I get 131 and 88 feet. Well, good gravy. Isn't 132 awfully darn close to that? I'd say it is. There you go. All right, let's take a look at this one. You have this circular concrete patio, and we know the circumference. It's about 1,400 feet, okay? The gardener is going to walk directly from the edge of the patio to the center, okay, from the edge to the center to get at this plant. And I don't know how far it is, so we got to find that first, and then we have to find how long it's going to take him. So let's do one thing at a time. Circumference is pi times diameter, okay? I don't know the radius, so that means I don't know the diameter. The only thing I do know is that this is about 1,400, okay? We also know that pi is either about 22/7 or 3.14. I'm going to use 3.14 this time for pi, and then I don't know what the diameter is, okay? So hang on. This kind of has multiple steps to it. So 1,400 is about 3.14 times whatever my diameter is. So if I'm trying to figure out diameter, divide or undo this multiplication by dividing by 3.14. Holy Hannah, I am really using my calculator now. All right. By the way, if I use 22/7, you can do that too, but let's just use this. Holy mackerel, I get a huge decimal. All right. I get 445.86 approximately. I'm going to round this off. Okay. About 0.86. Okay. Psst, that's diameter. Remember, diameter went all the way across. So now let's go one more step. Tell me what the radius is. If this is the diameter, radius is exactly half of that. So take half of that, divide by 2. 445.86 divided by 2. I get 222 and 93/100. Okay, that's my radius. That's the feet. That is how far the gardener, bloop, 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 has to walk. Bloop, 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 bloop. They're going to go a distance of 222.93 feet to get from the edge of the patio to the center where this plant is. Now, how long is it going to take him to do that? Okay, so this is the radius, and the gardener's going to walk the radius. How long is it going to take? That gardener is walking 1.5 feet per second. So if I have to go this many feet, and my speed is 1.5 feet per second, now take the 222 and 93/100 and divide it by 1.5. Okay? So I'm going this many feet. It's going to take me 148 and 62/100 seconds to walk that far. How long is that? Well, at 60 seconds every minute, take off a 60 That'd leave me 88. Take off another 60. I'd have 2 minutes and 28.62 seconds. I'm not so sure we have to be this completely accurate, but it'll be about 2.5 minutes is about how long it's going to take. Let me oomph that up a ways. Sometimes I forget that I've got my big old face in the way. So your final answer after all of that work is either 148 and 62 hundredths seconds or 2 minutes and 28.62 seconds. There you go. All right, I think we've got 2 other ones on here. Awesome. Imagine you could put a Fitbit on the end of this minute hand, okay? So think of, like, take a minute, look at the clock in the classroom, because the clock in the classroom has a red second hand, I should say, not minute hand, but the second hand. Okay, it keeps spinning, spinning, spinning. This particular one is 7 inches long. Draw that in there. That's a radius. The radius is 7. I'm asking you, if we put a Fitbit on there and kept keeping track of all the distance this thing is traveling, how long has this thing gone in an hour? In 1 minute, I've gone once around the circle, okay? So 1 time would be equal to the circumference. In other words, that one trip, which took 1 minute, is 1 circumference. Now, if I'm talking an hour, that would be 60 minutes, which means I'm going to have to find 60 times the circumference. All right? That's what we're looking for. 60 circumferences. All right, well, you know what the formula is for circumference. It's pi times diameter. Okay. I have 60, okay, because I'm doing the full hour, times pi, and let's see, why don't we just use 3.14? Because that's what we usually use. And then times diameter. And the hold on. Radius is 7. The diameter is twice as long, so the diameter is 14. Here's the math you've got to do, people. Okay? 60 times 3.14 times 14. Oops. 60, 3.14, 14. I get 2,637 and 6/10 inches. Holy mackerel, that's a lot. If you divide it by 12, that'd give us over 219 feet. Okay, 220 feet about. Not quite a football field, but close. Cool. Or what if we, instead of doing it this way with 3.14, if I said take 60 circumferences times pi, but this time use 22/7 times 14. And watch what happens here. Because I'm so stinking old, I could even do this math problem almost without a calculator, because 60 is like 60 over 1. 22/7, 14 over 1. Now here's the cool part. My denominator is going to get wiped out because 7 is a factor of 14. And that becomes a 2. So really, I have 60 times 22 times 2. Yeah, is that gross? Still, I guess. 60 times 22 times 2 is 44. Now take 60 times 44. If you have the oomph to do that one, go ahead. Otherwise, grab your calculator. And if you use this approximation, you get about 2,640 inches. Okay? If you use 3.14, you get that many inches. hey, they're pretty darn close. And when we're approximating with pi, we're not going to get a super exact answer. We'll get something close. So simply read your directions and see which approximation they are instructing you to use. Last one, Ferris wheel. This is kind of the same thing. You're up in the Ferris wheel. You go around once. That's one circumference. Go around 15 times, and that's a pretty good Ferris wheel ride. If you counted all of that distance, let's see how much that is, okay? This time they're telling you the diameter all the way across is 56 feet. So I already know my value of D, 56 feet. Circumference is pi times diameter. The diameter is 56. For pi, go ahead and use 3.14 for this time. And let's figure out what you get. 3.14 times 56. What are we in? Feet. Okay? That many feet. That's one circumference. Hold your horses. We're going around 15 times. So 15 times means we're going to take 175.84 and multiply it by 15. Now we're cooking. Doesn't this eerily look like the problem before? Yes, it does. Weird. Did I do that on purpose? That's bizarre. Okay. If you used 22/7 instead of 3.14, we would take 22/7 times 56. Okay, and when you do that one, you would end up with, let's see, 22 times 8, 160, like 176. Oh, see how close that is? That's for one circumference. If we're going to do that 15 times, then take 176 times 15. Holy cow. Is this weird or what? You get the same number. Interesting. Cool. All right. So you're masters now of doing circumference problems. So what I want you to do is look on Schoology and see what your assignment for tomorrow is. If you get all done with everything, you can always chip away on things with IXL. Good luck, and may the force be with you.